I'm going to do a lecture today for Math 150. This is in Chapter 2, and we've already talked some about linear equations. We did some of the linear regression topics, but now we're getting into the second section where we're just looking at linear equations and talking about solving them. So I want to go through some of these that we haven't had time to go over in class. So if you see with these, solving each linear equation, now of course every linear equation can look a little different, right? So we're going to talk about just different ways of solving equations depending on how they're set up. So for these examples here, both of them have the numbers outside of the parentheses. So when you have a number outside of parentheses, remember we're going to distribute that in right here. So that means we're going to multiply this number times any item that's inside of the parentheses. So that's what I did in my first step. 4 times x gives me 4x. 4 times -6 gives me a -24. On the right side, I just leave it as it is, 12 plus x. And then what we're trying to get to is we want x to be by itself. So we're going to start by combining the x's. So I want to bring this x over to this side to be with 4x. And the way I do that is I do the opposite, right? So it's added over here. So I'm going to subtract it to bring it over to this side. So when I subtract, these cancel out, right? And 4x minus x gives me 3x. So now I've got 3x minus 24 equals 12. So now I want to get this constant, so this number, to go over with this number. So I'm going to do the opposite again. Here I'm subtracting, so I'm going to add 24 to both sides. Over here, I'm doing that just so it'll cancel out. Over here, 12 plus 24 gives me 36. So now I have 3x equals 36. And so again, I want x by itself, so I'm going to divide both sides by 3, and I end up with x equals 12. And the nice thing about when we're doing these linear equations is we can always check our answer. So if I want to plug it in and see if I did it right, I would do 4 times 12 minus 6, right, should equal 12 plus 12, right? So anywhere there's an x up here, I'm just plugging in the 12. So 12 minus 6 is 6. So over here I'll have 4 times 6, which is 24, right? And 12 plus 12 is 24, so it works, right? So that tells me that I did the problem right. So one of the things I like about solving linear equations is that I can find out if I did the answer or if I got the answer right just by checking it. So now I know that since those check out, that this is the correct answer, x equal to 12. Okay, over here I did kind of the same thing. Again, we had a number outside of the parentheses that we distribute in, right, which means multiply. Also over here, don't forget about if you have a negative outside of parentheses, that negative has to apply to everything in the parentheses. So I ended up with a -x and a -5, so don't forget to do that. Okay, on this next problem, we see some tricky linear equations, which just means ones that sometimes can be a little more difficult to solve, and that's anytime we see fractions or decimals. I think we know in math, anytime they throw a fraction in there, it can be harder than just a basic whole number. So when we're working with fractions, especially if you're doing it more by hand and not so much in the calculator, it's easiest to work with it if we can get rid of the fractions. And so the way to remove the fractions is to multiply by the least common multiple or least common denominator, however you want to think of it. But if we look at our two denominators here, we have 4 and 5. And so if we think of all the multiples of 4 and 5, so 4, we would have 4, 8, 12, 16, 20, right? 5, we would have 5, 10, 15, 20. The smallest number that they both have in their multiples list is 20, right? So we're going to use 20 and we're going to multiply everything on this side and everything on this side by 20. So even if it doesn't have a fraction like this part, it still needs to be multiplied by the 20 to keep it equivalent. So I'm going to do 20 times the left side, 20 times the right side. Again, we're distributing in the 20, so 20 times 3/4 is equal to 15. And then we have our x minus 20, because 20 times -1 gives us a -20. And then over here, 20 times 7/5 gives us 28. Of course, you can put those in the calculator. You don't have to do those off the top of your head. You can put them in their calculator. And then again, what we're working towards is getting x by itself. So I need to move the 20 over to this side. So I'm going to add 20 to both sides. I get 15x equals 48. Then to get x by itself, I divide both sides by 15. And so my answer would be 48/15. But then usually we want that as a simple fraction. We want it simplified. So the final answer you would put actually into your homework as your solution would be 16/5 if they ask for it as a simplified fraction. You can do that in the calculator by just putting in 48 divided by 15. And then if you have the graphing calculator, you just push, after you've put in 48 divided by 15 and enter, then go to Math, the Math button, and click number 1, which says FRAC, which is for fraction, and then push enter again, and it will give you the simplified version of that fraction. Okay, then for decimals, decimals aren't as bad. A lot, we're going to put those in the calculator, so it may not seem like you need to remove them, but if we are going to remove those, we're going to multiply by powers of 10. So if you only have one decimal place, you want to multiply by 10. If you have 2 decimal places, you'll multiply by 100. If you have 3, you'll multiply by 1,000, etc. So in ours example up here, because we had 2 decimal places on these, we need to multiply by 100. We multiply both sides by 100, and we end up getting down to our answer here, which is 5/17. We can also check our answers graphically, and you can do that by graphing them. So if we've got these 2 sides of the equation, we can graph both sides and then see where they cross. So here, what I would do is on the calculator, I would push the y equals. There's a y equals button that's right up here. Looks like y equals, and you push that one. And then I'm going to put the left side of the equation in this first y value. And then in y2, I'm going to put the right side of the equation. I'm not even simplifying it. I'm just putting it in just like it looked up here. Then you're going to click graph. And you may have to zoom or change your window. It just depends on what you're graphing. But you can always go to the zoom button, which is also up here. There should be 5 buttons here. Okay, and zoom is the one in the middle. So it says zoom. You're going to click on that, and you can do Z standard, which takes you to a -10 to 10 on the X and the Y axis. You can zoom in and out, whatever you need to do until you can see the lines crossing. So we can see here that where they cross, that point right there is the intersection, and that is the solution to this problem, is where they cross. So sometimes you can just tell where it is, like you can actually count the spaces, but this one is a little harder to tell. So you can go to second of the trace option. Trace is this button right here. So you push second and trace, and that's the calculate area, and we're going to choose the intersect. You press enter 3 times just to show which lines you're looking at, and then you get this as your output, so it shows that your answer is x equal to 6, which is also what we got up here. So you could check your answer that way, or if you want to actually solve the problems that way, you can do it that way as well. Okay, so in most of the cases that we're going to solve, we're going to come out with an answer of x equals to some value. But there are two special cases where you'll either get no solution or you're going to get all solutions, so every value is going to work. So in the no solution case, you're going to end up with something that doesn't make sense. So here, when we're trying to solve for x, we end up removing the x on both sides, and we're just left with 3 equals 10, which of course is not true, right? 3 does not equal 10, so that means there's no solution for this problem. There's no value for x that I can plug in here and here that's going to make these two sides equal. Now on this side, when I solve for x, I end up with negative 2/5 x equals negative 2/5 x. Now that's always going to be true, right? So any value of x that I plug in, I could plug in 0.9, I could plug in 8,000, I could plug in 3/4, I could plug in anything, right? And this would always be true. So when it's always true, then we would say the answer is all real numbers, so everything's going to work. And so those are the two kind of special cases. Most of the time we get what's called a conditional solution, where x has to be equal to a certain value. Okay, and then we come to applications using linear models. So I tried to give you some of the examples that you might see on your homework, but you could see others as well. These are just the main ones that usually we'll see. But you could use linear models with a lot of different applications. But the first one we're going to look at is something having to do with sales tax. It could also have to do with a discount that you had on something you bought. So it says a pair of shoes cost $72.40 after the 6% sales tax is added. How much was the original cost of the shoes? And so this also could have said something like a pair of shoes cost $72 after you had a certain discount added or whatever. So you're kind of going to do the same process, just set it up based on what numbers you have. So when we're talking about the total price we're going to pay for something, we have the cost of the item, and then we also add on the tax, right? And so that's what we're doing in this scenario, is we have a cost, which is what we're trying to find, and so the original cost of the shoe we're going to call X. Okay, so that's our X. Then we're going to add on the tax. Now, here we're doing a 6% sales tax. And the way that's calculated is we take 6% times X, right? So 0.06 times X, 6% becomes 0.06 because we divide 6 by 100, and that's what gives us the 0.06. So now we're left with this equation, x plus 0.06x equals 72.40. We add these two together, and that's 1.06x equals 72.40. And really all we're left with is just dividing both sides by 1.06, and we get 68.30 for our final answer. So when we pay for an item, if we had a 6% sales tax, we're really paying 106% of the original price, right? Because we're paying 100% of the price because that was the cost, and then that extra 6% because that is the tax. Okay, now this one takes a little more time. This one we're looking at a simple interest example. And so when we're doing simple interest, we do want to remember the simple interest formula. The simple interest formula is the interest equals P times R times T. So I is your interest, your simple interest. The capital P, that's your principal, which is the amount that you put into the account or that you have in an account. That's the starting value. R is your rate, so the interest rate that you're going to have. And we always put it in as a decimal, so make sure you convert your percentage to a decimal. And then T is the time in years. So this one says you were inherited $16,000. For the first year, your money's going to be in two investments. One of them pays 6% and one is 8%. So the 6 and the 8%, those are your rates. And it says how much was invested at each rate if the total interest for the year was $1,180. So that's your total interest that you earned. And because we're just doing it for the year, our t value is just going to equal 1 because it's just 1 year. So when we're doing these problems, we always have to define what x is. So in this scenario, x was the original cost of the shoes. For this one, you've got to choose what you want x to be. Now there's two amounts we're trying to find. We're trying to find the amount that we deposited at 6% and the amount that was at 8%. So one of those values needs to be x. It doesn't matter which one you choose, but you just need to make sure you label it. So I'm going to let the 6% amount be x, and then that means that the 8% amount is going to be 16,000 minus x. And I get that because we know we started with $16,000, right? So if I put $10,000 in this account, I'd have $6,000 in this account, right? So whatever I put in the 6% account, the leftover is going into the 8% account. So both of your values here are going to be based on that x, right? So you don't want to introduce like a new variable here, like I'm going to call this one x and this one y, because then you're solving an equation with two variables, and we don't want to do that, okay? So we want everything to be based off of just an x, okay? So when we look at our simple interest formula, this P times R times T is going to give me the interest that I got from the 6% account, and then this P times R times T will give me the interest that I got from the 8% account. When I add those two interests together, I'm going to get my total interest that they told me was $1,180. So let's look at how we'll find these values. So for the 6% account, we said the amount was going to be x, so the principal is x. The rate is 6%, which we'll have as 0.06, and the time is 1 because it's 1 year. For the 8% account, the principal is the 16,000 minus x times the rate of 8%, which is 0.08, and then again it's just for 1 year, so it's times 1, and that's all equal to 1180, right? Once we have all this filled in, then we're just solving the problem. So here we're distributing in that 0.08. On the green side here, we just have 0.06x plus this simplifies down to 1280 minus 0.08x equals 1180. We want to combine our x values. So 0.06 minus 0.08 gives us a negative 0.02x. When we bring this to the other side, we end up with negative 100. So we have negative 0.02x equals negative 100 divided by negative 0.02. And this would give us x equals 5,000. Okay, so once we get our answer here, x equals 5,000, then we have to look back and say, well, what was x, right? X was the amount at 6%. So at 6%, I'm going to have $5,000, and then the leftover is going to the 8%, right? So 16,000 minus 5,000 is 11,000. So that's how I get those two answers. So you want to make sure at the beginning that you identify which one is x, so that at the end, when you're trying to decide, you know, which answer goes where, you can go back and see what you labeled x as. All right, and then our last example here is looking at averages. So for an average, we have to know that an average is equal to the sum of all the values divided by the sample size or divided by your total number of data points. So it says a basketball player wants to have an average of 30 points in his last 5 games. He has scored 32, 28, 33, and 22 in the past 4 games. So what does he need in game 5 to get an average of 30? All right, so if we need to find the sum, we're going to have 32 plus 28 plus 33 plus 22 plus x. So this is our game number 5 here, right? That's what we don't know. Our sample size is going to be 5 because we're talking about 5 games, right? 1, 2, 3, 4, 5. So now we're just going to solve. We start by multiplying by 5, so 30 times 5 here gives us 150. We add up all of these values and get 115 plus x. So we do 150 minus 115, which gives us 35, and that is going to be our answer. So x is equal to 35. So if I plugged a 35 in here and I worked this out, I should get 30, right? So you can always go back and check your answer if you need to, right? Okay, so that was the end of this section for Chapter 2 in Math 150. If you have any questions, remember you can always email me at angela.galloway@kctcs.edu. You can also send me emails through the Cengage that you're working on your homework. You can let me know if there's any examples you would like me to rework in class, and I can make sure we have time to do that. But let me know how I can help you. I don't want you to feel like you're on your own trying to figure this stuff out. So please contact me if you have any questions. All right, I'll see you soon. Bye.